So welcome back, guys. This is IPv4 addresses is what we're tackling now. This is definitely going to be a multi-part video. There is no ways we can get through everything to do with IP addressing in a single video. It's just not going to happen. So this is going to be a multi-part video, and it is going to have some of the most important things when it comes to the entire idea of networking. If you don't understand how IP addresses work, you're dead in the water from the get-go. Now, although we're going to focus initially on IPv4 addresses, of course we are going to evolve that into IPv6 at some point in these video series, and we'll discuss how all of those work from an IPv4 and an IPv6 perspective. Now, because IPv4 is still the most commonly used and worldwide still used IP address, it is still probably the most important one that we cover first. And then, of course, we'll dive into IPv6 as we continue. Now, the IPv4 address structure, this is the first little piece of the pie that we want to have a look at. And I'm going to bring up Notepad here real quick, just so we can see how it looks. So let's have a look at an example of an IPv4 address. This is my local laptop. If I do an ipconfig real quick, there is my wireless adapter, which is what I use to connect here at my home office. And there is my IP address. 192.168.1.114 with a subnet mask of 255.255.255.0. So let's leave this over here on the side so we can reference that. One of the most important things to understand with the structure of IP addressing is that it is based on 8 bits followed by 8 bits followed by 8 bits followed by 8 bits. These are called octets, and the reason why it's known as a octet is because, of course, oct meaning 8. And there are 8 bits, 8 ones or zeros, that make up the numbers separated by the periods. So we have a total of 4 separate octets that make up an IP address. Now, the idea with an octet is we are looking at a 2-base number system. It's binary structured. Now, although when we read an IP address, we can see it here in decimal notation, it is not represented. These 8 bits are not representatives of decimal. They represent, it's a representation, of binary. So what we're looking at with 8 bits with binary is we're looking at an equation of 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 3, 4, 5, 6, and 7. And what you will find is if you take a calculator and work out what the values are, you end up with a table that looks like this. And this is probably one of the most important tables you'll ever see. So what we're seeing here is 1 is 2 to the power of 0. 2 to the power of 1 is 2, 2 to the power of 2 is 4, and as we go through up until we get to 2 to the power of 7 is 128. Now, these are our 8 ones or zeros. These are our 8 bits. This is the 8-bit structure that we're looking at. So within those 8 bits, what we're saying is that an IP address could be anything that is zeros, which of course if we add those all up, it's still equal to good old nothing, or we can turn on each of those bits into a 1. So if I turn on all of those bits, that gives me a grand total of 255. Right? That is the maximum number that can be created with binary in an 8-bit system. Right? If we've got 8 bits to play with, we can have 256 combinations. Now you hopefully picked something up there. I just said 256, but the number here is 255. Please do not fall into the trap that so many people do, which is to forget to count 0. 0 is actually the first number, which means that 1 is actually the second number, 2 is actually the third number, and so on, which means that 255 is actually the 256th number that we have represented. So we get 256 possible combinations that we can have per octet. So that means in theory an IP address could have any value between 0 and 255 in each octet. Right? Now that is how an IP address is structured, how it's written. So these are the different types of numbers that we can use. Now, more to the point of how an IP address is structured, as we can see with my PC, it says that my IP address is 192.168.1.114, and we're going to learn a lot of things about that kind of IP address moving forward. More to the point of interest here is what's called the subnet mask. The subnet mask in my case is 255.255.255.0. Now, what's so important to understand with an IP address is that some of it represents the name of the network, some of it represents the host, the individual. And that host would be a laptop, it would be a printer, it would be any kind of device that is connected to the network. That would be the host device. Now, what's important to also understand, and I use this example if I teach classes in face-to-face, so this is an ILT class per se, is I would always say to the students, well, hey, when you arrived here in the building, they told you to come up to floor 3. Once you got to floor 3, there wasn't just 1,000 people standing in a big open shell, right, in a construction site with 20 instructors who are all talking and you're trying to figure out who you're supposed to listen to. We break down that floor, that entire floor, floor 3 or whatever floor number it happens to be, we break that down into classrooms. And each classroom will then have people that are trying to listen to a particular topic. So whether it's a ICND 1 class, for example, would put you into Studio 1. If you were here for an ICND 2 class, would put you into Studio 2, and so it would progress. Now, this is exactly what IP addressing does as well. So IP addressing doesn't just say, well, here's a bunch of numbers, have at it. It breaks it down into multiple pieces to say some of these represent the classroom that you're going to belong to. And then we're going to represent you as the individual. So you as the individual are in Studio 2 for a class. Well, Studio 2 is the network, and your name would be the host portion. Now, what a subnet mask does is tells us which pieces of the IP address are network related, the name of the network, and which pieces are host specific. So keeping it at the highest level possible, what 255 means is that is a representation of network. Now, it's not so much about the number 255. It's about the fact that the bits are turned into ones. So we need to look at this, hopefully, in a binary notation, which is to say, well, we've already seen what 255 looks like in binary, right? There it is. So this written in binary is actually 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. That is what the subnet mask would look like in binary. Now, what we're saying is, if the number is equal to a 1, then the corresponding bit in the IP address is the network. So in this case, do we agree that this entire octet are all ones? Right, so if the entire octet is all ones, then that says that the entire first octet is part of the network name. The second octet is all ones, which means the second octet is all part of the network. And the third octet is all ones, which means that is again part of the network. However, in the final octet, the fourth octet, they are all zeros, which illustrates that these are part of the host portion. Now what this does is tells me a few things. It tells me that the network, in my particular case here with my IP address, it tells me that the network happens to be a network of 192.168.1. That is the name of the network. And me as the individual inside of that network is .114. So my laptop is actually .114 belonging to a network called 192.168.1. So when we represent a network as a whole and we want to talk about the network, I don't want to talk about anyone in particular, I just want to talk about the whole network as a whole, then what I will always do is use the very first possible number in binary. This is really important to make sure that you're getting this. The very first number in binary for the host portion. So, do we agree, if we look at this, that 0000, all of those in the subnet mask means that entire octet is hosts? And if I was to write the lowest number possible in binary, that again would be all zeros. So by representing a 0, this is actually the official name of the network. So the name of my network at home right now is 192.168.1.0. That is not talking about anyone in particular. That is talking about the network as a whole. However, inside my network, I have many PCs. I have many devices. I have many machines. I have a lot of IoT and so forth. Each of those will have a host name. As part of the IP address, it'll have a host IP. My laptop happens to have .114. So this is the structure of what IP addressing is based on. Now there's a lot more to it, and of course we're going to go into this kind of detail in the following videos, but one thing I do want to help you out with immediately at this point is that I can actually write an IP address in an easier way. So I could say 192.168.1.114, as we've seen as my IP address, /24. And what /24 tells me is how many bits are turned into ones in the subnet mask. Let's have a look at my subnet mask again. My subnet mask is 255.255.255.0, which when we converted into binary was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 sequential ones. And that's exactly what this is now representing down here, which is a /24. So you have got a few choices as to how you want to represent or write the number. /24 is a lot easier. It's a lot quicker to write it, especially if you're physically writing with pen and paper. But neither is wrong. So whether we write an IP address with a /24 or write the subnet mask out in its entirety, it is the same thing. Now, you will notice in some configurations, we have to type in the subnet mask in its entirety. In other types of configurations, we are actually allowed to type in the prefix mask, or otherwise known as CIDR, so it has multiple names, or /value as some people call it. But the /24 value is what we're looking at there. So this is the IP address structure. This is how an IP address is comprised, and this is how it is built. So hopefully now you've got some better insight as to how an IP address is structured. In the next video, and remember I did mention this is a multi-part video, it has to be because we have so much to go through. This was just the structure of the IP address. We're also going to dive in now to how network numbers work, how to write stuff in binary and decimal, and how to convert that. So that's all coming up in the next videos as well. If you haven't hit the subscribe button yet, please do so. Hit the like button as well, and by hitting subscribe, you'll get a notification every time that we upload a new video, part of our series. Thanks for watching and have a great day, and we'll see you in part 2.